Hi everybody, my name is Xuan Zhuang. Cooperated
This is
with two
our
professors, Xu Zhenyang and Dayue Gao from the Central Police
First,
University in
introduction.
Taiwan. Our presentation today is
The
about
easy
drone forensics.
accessibility of drone
Drone
capabilities
forensics
has
has
led
led
to
to
an increasing need for
flight data
forensic
and help
analysis from the
investigators
crime scene
establish
and the
ownership.
related device. Many criminal lines control many drones in illegal activity, creating new forensic challenge. Crime related to drones are also enlarging. The forensic analysis of captured drones is fundamental and necessary to determine who controls the drone and the mobile phone. The paper presents the identification, collection, examination, analysis, and presentation of the recorded data from the two drones and their related controllers. The forensic analysis of flight data compares the relational flight data and explores the association among drones, mobile phones, and SD cards. 2. Background. The background of the paper is related to some knowledge about drones, drone forensics, and Euclidean distance. A drone is controlled remotely by a pilot on the ground or by a series of onboard electronics. Many kinds of flight payloads can be attached to a drone to make it widely used. The communication between a drone and a controller is through wireless communication. Through wireless communication, like Wi-Fi or Bluetooth, digital artifacts from drones can be transferred to controllers. There are some common payload types of drone. 1. Sensor. Sensors can provide artifacts about the flight situation, like wind speed and atmospheric pressure, to stabilize drones. 2. Camera. Cameras are useful payloads for criminal investigation or drone forensic. The photos and video recorded by cameras can provide the timestamp, GPS data, and other artifacts. Next, we are talking about digital evidence and digital forensics. About digital evidence, the data related to drones are digital artifacts. In general, a drone has internal storage to store flight artifacts. Drone photos and videos are stored on the SD card. Drone equipped with Wi-Fi hotspots may provide someone's GPS position. The forensic analysis of flight data, photos, videos can be useful to reconstruct incidents. About digital forensic, a drone and a controller rely on wireless communication to transfer data. According to low-card exchange principle, every contact between two items will leave a trace. To compare the digital data in the two devices and find out their relevance between each other can make the digital evidence acceptable in a court of law. The investigative processes of digital evidence are identification, collection, examination, analysis, and presentation. Euclidean distance represents the distance between the 2 points in Euclidean space. This mathematical method can be used for calculating the similarity between multidimensional data. Third, experiment design. Experiment setting. We assume that the DJI Spark and the DJI Mavic Air were engaged in illegal drone activities at a similar time at a similar place. Law enforcement agencies subsequently collect the two drones, the SD card inside, and the two mobile phones controlling the two drones. However, law enforcement agencies didn't know the relationship between mobile phones and drones. There are two experimental sets. In this experiment, we will identify the association among this item. Environment setting about software. In the laptop, we set DJI Assistant Tool for identification, FTK Imager for collection, EXIF Tool GUI for examination, Air Data for analysis, and Excel for presentation. And in the two mobile phones, Samsung S7 and Samsung Tab 3, we set DJI Go to control the two drones. Fourth, experiment process. Process 2, data collection. The nature of Wi-Fi wireless communication may cause variable packet, delay and loss rate. Process 3, data examination. The JPG files in the two SD cards can provide timestamp and GPS data, but those JPG files in the two mobile phones did not record GPS data. Only JPG files timestamp data can be compared to determine the relationship between SD cards in the drones and mobile phones. Process 4, data analysis. Drone forensics can be analyzed using some toolkits and comparing the flight data to explore a drone-related crime and reconstruct an incident. Fifth, experiment presentation. Set 1 is about the DJI Spark, Samsung A7, and SD card. Table 4 is about GPS data comparison between DAT files in DJI Spark and Samsung A7. There are all 14 DAT files in the drone and on the mobile phone. The GPS data is collected from the CSV files, converted from the DAT files by the Air Data Online software. In the table, every column presents the takeoff GPS data or flight records collected from the DAT files in DJI Spark and Samsung A7. And Figure 1 is the scatter diagram of GPS data. In the diagram, every spot presents the takeoff GPS data or flight records in the drone and the mobile phone. The Euclidean distance examined to explore its relevance. Table 5 presents that the drone's GPS data and the mobile phone's GPS data are very relevant to each other. It further demonstrates that the Samsung A7 controls the DJI Spark drone. Next, we discuss about the timestamp comparison between JPG files in Samsung A7 and SD card. In Table 6, there are the JPG files in the SD card of the DJI Spark and the Samsung A7. In SD card, there are 41 JPG files named DJI with some number, and in the mobile phone, there are 41 JPG files named Thumb with some number, and 20 JPG files named Screen with some number. In Figure 2, we can see that the JPG files timestamp in the SD card is close to the JPG files named Thumb with some number in the Samsung A7. But the timestamp of JPG file named Screen with a number is different. The Samsung A7 may automatically recall the JPG file named Screen with a number. Step 2 is about the DJI Mavic Air, Samsung Tab 3, and SD card. The DJI Mavic Air flew 16 times in the experiment. The GPS data in the Samsung Tab 3 was collected from the CSV files converted from the DAT files. Nevertheless, the DAT files in the DJI Mavic Air are encrypted. This is an experiment limit. We cannot analyze the GPS data from the DAT files in the drone to determine their association with the Samsung Tab 3. Then, we discuss about the timestamp comparison between JPG files in Samsung Tab 3 and SD card. The photos were recorded randomly by pressing the shutter on the mobile phone. There are 30 JPG files in the SD card in the drone, and there are 18 JPG files in Samsung Tab 3. Excel created a timeline graph in Fig 3 to compare the JPG files timestamp in the drone SD card and the Samsung Tab 3. The Samsung Tab 3 is connected with the DJI Mavic Air through a Wi-Fi connection. There is a possibility that the data could be remotely wiped. Research findings. First, GPS data from DAT files from the drone and the mobile phone. The relevant association between two connected devices can be found by analyzing GPS data from DAT files in the drone and the mobile phone. Although the GPS records are not entirely the same, with the Euclidean distance formula, we still can find a high relevance correlation between the drone and the mobile phone. Second, JPG files from SD card and mobile phone. JPG files from the SD card and mobile phone can provide timestamp data. Because of network delay, the timestamp of JPG files in the mobile phone will be recorded later than those in the drone. In the DJI Spark experiment, the mobile phone automatically recorded some JPG files. But in the DJI Mavic Air experiment, the mobile phone only recorded JPG files taken manually by pressing the shutter. Third, experiment limit about data loss. In the DJI Mavic Air experiment, some JPG files are lost in the later flights. An unstable application program may cause missing data when media was recorded. Data missing increased the difficulty of the association between SD card and mobile phones. Experiment limit about encrypted files. According to the introduction of CSV view, the DAT files in DJI Mavic Air, DJI Mavic 2, and DJI Mavic Mini drone are encrypted and cannot be processed. The drone's GPS data cannot be collected from the DAT files in the DJI Mavic Air drone. The comparison of GPS data in the drone and the mobile phone cannot be performed. Therefore, the association between the drone and the mobile phone cannot be proved. The two-set discrimination can be made by analyzing the flight files of drones, SD cards, and mobile phones. The relevant correlation of collected flight data from 3 items can be calculated through the mathematical method. This forensic analysis can determine the relevant evidence among drones, SD cards, and mobile phones. The decryption of encrypted files and multiple observations on more drone experiments will be explored in the follow-up study. These are our references. Thank you for your listening.